A cool new way to beat the heat. On a hot, sunny day, everything heats up. Cars, sidewalks, rooftops, air conditioners help, but they use lots of electricity and worsen climate change. What if we could cool buildings without any power at all? Scientists from around the world have just created a revolutionary coating that does exactly that. Using artificial intelligence, they designed a new class of materials, thermal meta-emitters, that can cool themselves under the sun. This breakthrough could transform how we keep our homes, cities, and even ourselves cool. Let's dive into the science behind this game-changing innovation. Get ready to see how the future of cooling is smarter, cleaner, and cooler than ever. Section 2. Meet the meta-emitters. A revolutionary approach to thermal management. Your new best friend on a hot day. As temperatures rise, finding effective ways to stay cool becomes increasingly crucial. So, what exactly are thermal meta-emitters? Let's delve into the science behind these innovative materials. Imagine a coating engineered at the nanoscale, a level of precision previously unattainable. Smaller than a speck of dust, a feat of modern engineering that redefines material properties. This coating can control heat and light in ways nature never could, offering unprecedented control over thermal dynamics. These materials are built from intricate 3D patterns, meticulously designed at the atomic level. Each pattern is designed for maximum cooling, optimizing the way heat is dissipated from surfaces. Designing them by hand would take forever, an impractical task given the complexity of the structures involved. So researchers used AI, leveraging its computational power to accelerate the design process. The AI was used to test thousands of designs in virtual simulations, rapidly iterating to find the most effective solutions. The AI learned which patterns best reflect sunlight, minimizing the amount of solar energy absorbed by the material. It also learned to radiate heat away, efficiently expelling thermal energy into the environment. This process is creating coatings that outperform anything we've seen before, setting new standards for thermal management. The result? A paint-like material that's simple to apply, making it accessible for a wide range of applications. But it's packed with microscopic complexity, a testament to the power of nanoscale engineering. This AI-driven process marks a significant shift in how we approach material design and development. It lets scientists rapidly invent materials with custom properties, tailoring solutions to specific needs and challenges. Instead of slow trial and error, a method that often leads to incremental improvements at best, we now have a fast, creative way to explore a vast design space. This allows us to build the perfect cooling solution, optimized for efficiency and sustainability. These meta-emitters are a leap forward for material science, pushing the boundaries of what's possible. They're not just better, they represent a paradigm shift in how we think about thermal management. They're built for the job, designed from the ground up to meet the specific demands of modern cooling challenges, science rules, and these meta-emitters are a prime example of how scientific innovation can improve our lives. Section 3. The Ultimate Rooftop Showdown: Meta-emitters versus plain old paint. We're diving deep into a head-to-head comparison of cutting-edge cooling technology against traditional methods. Do these new materials really work? Are they just hype? Or can they truly revolutionize how we keep our buildings cool? Researchers put them to the test on rooftops, under real-world conditions, comparing them to standard white, the go-to choice for reflective roofing, and gray paints, which are commonly used but known to absorb more heat. After hours in the sun, baking under the relentless heat, the meta-emitter-coated surfaces were up to 20 degrees Celsius, 36 degrees Fahrenheit, cooler than regular paint. The difference was striking and immediately apparent. That's a massive difference. A testament to the power of this new technology, enough to keep a roof cool to the touch on a scorching day. Imagine walking on your roof barefoot in the middle of summer. This translates to huge energy savings, reducing the strain on our power grids and lowering your bills. One apartment building could save over 15,000 kilowatt-hours of electricity per year. That's enough to power several homes. The secret? What makes these meta-emitters so effective? Meta-emitters reflect sunlight like a mirror, bouncing away the sun's energy before it can even heat the building, and radiate heat directly into space, acting like a natural air conditioner for your building. Something regular paints can't do. They simply absorb and trap heat. They don't just block heat, they go a step further. They actively push it away, sending it back into the atmosphere. This dual-action design is a total game-changer, offering unparalleled cooling performance. For keeping buildings cool, it's a smarter, more efficient way to manage building temperatures. Standard paints can't compete. They're simply outmatched by this innovative technology. With meta-emitters, the future of cooling is here. We're on the cusp of a new era in building design and energy efficiency. That's real innovation. It's a breakthrough that promises a cooler, more sustainable future. Now let's delve into one of the most brilliant and groundbreaking aspects of this technology. It's completely passive, requiring absolutely no external energy input to function. These coatings work entirely without electricity, a stark contrast to conventional cooling systems. They have no moving parts, which simplifies everything. This also means minimal to no maintenance is required, saving time and resources. Their cooling power comes directly from their carefully engineered structure, designed at a microscopic level. They achieve cooling by reflecting sunlight, preventing heat absorption, and radiating existing heat away from the building. Absolutely no external power needed. Unlike traditional air conditioners, which guzzle lots of energy, contributing to higher electricity bills and increased carbon footprint, and rely on harmful refrigerants that damage the ozone layer, meta-emitters offer a sustainable alternative, cooling buildings naturally and efficiently, providing consistent cooling all day long, without any energy consumption. This translates to significantly lower energy bills for homeowners and businesses alike, less strain on the power grid, especially during peak demand, and a substantial reduction in greenhouse gas emissions, contributing to a healthier planet. In some climates, particularly those with intense sunlight, they could potentially replace air conditioning systems altogether, offering a truly revolutionary approach to cooling. During extreme heat waves, when power grids are often overloaded and prone to failure, these coatings continue to work tirelessly, eliminating blackout worries and ensuring consistent comfort. Every rooftop equipped with this innovative technology becomes an integral part of the solution, actively contributing to a more sustainable future. It's a powerful step towards addressing our pressing energy and climate challenges, offering a pathway to a greener and more resilient world. It's a resilient, silent, and remarkably elegant way to stay cool, offering a sustainable alternative to traditional cooling methods. Imagine entire cities where buildings effortlessly cool themselves, reducing energy consumption and promoting a healthier environment, even during widespread power outages, ensuring comfort and safety for all. That's the transformative power of passive cooling, a game changer in the world of sustainable architecture. It's effortless, incredibly reliable, providing consistent cooling without any intervention, and perfectly ready for the challenges and opportunities of the future, offering a sustainable and resilient solution for generations to come. No complicated switches, no disruptive noise, just pure, cool comfort, naturally and sustainably achieved. That's smart science seamlessly integrated into our built environment, working silently and effectively to create a more comfortable and sustainable world. One of the most exciting things about this breakthrough is its incredible versatility. While rooftops are the obvious use, meta-emitters can be tailored for almost anything. Cities could coat roads and buildings to fight the urban heat island effect, making entire neighborhoods cooler and more comfortable. In space, these coatings could protect spacecraft from extreme temperatures, keeping electronics safe without using power. Imagine clothing that keeps you cool on a hot day, or cars that don't turn into ovens in the sun. Tents, backpacks, and outdoor gear could all benefit from this technology. The possibilities are endless. Wherever heat is a problem, meta-emitters could be the answer. This is more than a new paint. It's a platform for innovation across industries. From cities to space to your daily life, the impact could be huge. The future of cooling is everywhere. A discovery this big doesn't happen by accident, no. This breakthrough is the direct result of international teamwork, with scientists hailing from the US, China, Singapore, and Sweden. Led by Professor Yobing Zheng at UT Austin, the team combined their expertise in nanophotonics and AI to make the impossible possible. Their groundbreaking work was published in Nature, one of the world's top scientific journals, a mark of true excellence. This project clearly shows how global collaboration and cutting-edge tools like AI can solve real-world problems. The team is already diligently working on new applications and improvements. When science truly goes global, the results can change the world. It's a win for science, and ultimately for all of us. Let's step back and see the big picture. This isn't just a new kind of paint, it's a revolution in how we manage heat. By using AI to design materials atom by atom, scientists have unlocked cooling solutions once thought impossible. Cooling is one of the world's biggest energy challenges, and this technology offers a sustainable, passive alternative. It can bring comfort to places where air conditioning is impractical or unaffordable, improving lives everywhere. As the world gets hotter, innovations like this are essential for a sustainable future. We're entering a new era in materials science with endless possibilities ahead. This discovery is more than just cool. It's hope for a cleaner, smarter world. With science, collaboration, and creativity, we can solve our toughest challenges. That's why science matters, now more than ever.